Okay, today you guys are going to be looking at multiplying and dividing rational expressions. On Friday, all you did for me was simplify or reduce fractions. Today, you're going to take it one step further and actually multiply and divide those rational expressions. All right, so here we go. Up at the top, number one, we've got two fractions that they're asking us to multiply. We got 3/4 times 5/7. So the question is, how do you multiply fractions? You got to remember how to multiply fractions without a calculator. How do you do it? What? Yeah, you just go over to the side. You go straight across. So in other words, all you're doing is multiplying 3 times 5. What do you get when you multiply 3 times 5? 15. Then you do the same thing with the denominators. Multiply the denominators. 4 times 7. 4 times 7 is a 28. Then, of course, if you can reduce the fraction, you would want to do that as well. However, 15/28 cannot be reduced, so there it is. That's the answer to number one. So, what were the steps involved in multiplying those two fractions? All you did was multiply straight across. You multiply the numerator with the other numerator and the denominator with the other denominator. That's all you're doing when you're multiplying fractions. Straight across. Nothing fancy. So what we're going to do today is exactly the same thing with our rational expressions. You're just going to multiply straight across. So you'll notice over there to the right-hand side, they've given us two rational expressions. We've got 2 over x minus 4, and we're going to multiply that with x over x plus 1. So all we're doing is multiplying straight across, just like we did with our fractions. So if I multiply 2 times x, what do you get when you multiply the 2 times the x? You get a 2x. Do the same thing with the denominators. We're going to multiply x minus 4 times x plus 1. Now this is going to require a little more work. We're going to have to do some FOIL on this one. So if I multiply the x times the x, that's going to give me an x squared. If I multiply the x times the 1, x times 1 is 1x. If I multiply negative 4 times x, negative 4 times x is negative 4x. And a negative 4 times 1 is negative 4. So down at the bottom, I'm doing 4. Yes. Now, I'm not quite done yet. I'm going to clean that up a little bit. The numerator, of course, is going to stay the same, 2x. It's the denominator that I'm going to fix, because these two terms in the middle, they are like terms, which means I can combine them, which now means I have x squared minus 3x minus 4. This is what I get when I simplify the 1x minus 4x. So this right here would be the answer. And I do that simply by multiplying straight across. Nothing fancy. All right, let's take a look at number 2 now. Number 2, we have 2 times 4 over 9. Question is, what does that equal to? Well, what are we going to have to do to that 2 first? Anybody remember? What? Put a 1 underneath it. It needs to be a fraction. So we're going to put a 1 underneath the 2 so that we have a fraction. So now we're going to multiply the fractions 2 over 1 times 4 over 9. And as a matter of fact, I'm going to do exactly like I did number 1, straight across. 2 times 4 is 8. 1 times 9 is 9. Of course, if you can reduce it, reduce it. However, this one does not reduce, so we leave it as 8 over 9. So what were the steps involved there? Well, we put the whole number over 1 and then multiplied straight across. We turn the 2 into a fraction by placing a 1 underneath. Anytime we have a whole number, got to make it a fraction. Well, we're going to do exactly the same thing with our rational expressions. If it's not a fraction, we're going to make it a fraction by putting a 1 underneath. So they give us 2 examples to look at over here to the side. The first example is 3 times 8 over x plus 6. First of all, you notice the 3 is not a fraction. So we're going to make it a fraction by putting a 1 underneath it. From here, it's just a matter of multiplying straight across. So if I multiply the numerators, 3 times 8 would be a 4. Anybody know what you get when you multiply 1 times an x plus 6? X plus 6. And there you have it. That's the answer. When you multiply 3 over 1 times 8 over x plus 6. They give us another example here, very similar. This time we have x plus 1. Notice x plus 1 is not a fraction, so we're going to turn it into a fraction. How do I turn it into a fraction? Simply by putting a 1 underneath. Now it's a fraction. It's a rational expression. All right, so help me out here. I need to multiply x plus 1 times an 8. Anybody know what you get when you multiply x plus 1 times an 8?
8x plus 8.
There you go. 8x plus 8. You use distributive property. 8x plus 8 is what you get. What do you get when you multiply 1 times 8? X plus 6. X plus 6. And there you have it. All we do is multiply straight across. Of course, we did that after we turned the x plus 1 into a fraction. All right, let's go on to number 3 over here. Here we have 4/9 times 1/4. Go ahead and multiply straight across, see what happens. 4 times 1. 4 times 1 is 4. Now multiply the denominators. 9 times 4. What's 9 times 4? 36. And we reduce 4 over 36. Yes, anybody know what that reduces to? 4 over 36 would reduce to 1 over 9. That is correct. 1 over 9. Now there is a shortcut to getting from 4/9 times 1/4 directly to the answer 1/9. Okay, we can skip the 4 over 36 part. Does anybody see a shortcut way of getting it?
Cancel out the 4.
Cancel out the 4s. Notice this 4 right here and this 4 right here. We can cancel those out. Those are common factors, which means look what we're left with. We have a 1 for our numerator and a 9 for the denominator. Is that legal? Can we cancel out those 4? Yes, you can. So, in this case, the steps we use were to first simplify by canceling out common factors that we see both on the top and the bottom, and then multiplying straight across. We can use this same technique when it comes to rational expressions. Same thing we do with fractions. We can also do those with our rational expressions. If there's something we can cancel out, let's do it. It's going to save you a lot of time and a lot of headache. So if we take that same approach we did with the fraction over here with our rational expressions, notice there's a common factor. Notice there's something we can cancel out both in the numerator and the denominator. Can you spot it? What is it? X plus 3. Notice how this x plus 3 and this x plus 3 we can cancel out, which means we're only left with what for the numerator? X. And what are we left with for the denominator? X minus 4. And there you have it. That's it. That's all there was to number 3. So everything that we can do with fractions, we can also do them with rational expressions. All right, number 4. Here we have 4 over 15 times 5 over 6. Let's see what we get on this one here. If I multiply straight across, 4 times 5. 4 times 5 is 20. If I multiply 15 times 6, 15 times 6 would be 90. However, I can reduce 20 over 90. Anybody know what 20 over 90 reduces to? 20 over 90. 2 over 9 is correct. We can cancel out the common factor here, which is 10. So 2 over 9 would be our answer. However, there's a much faster, more efficient way of getting to that 2/9, skipping that 20 over 9. The question is, how do you do that? Anybody know a way that we can get straight to that 2 over 9? What's that? Well, I'm saying skipping the whole 20 over 9 part. What if we skip that part? How can we go straight from multiplying 4 over 15 times 5 over 6 directly to 2 over 9? All right, let me see if you remember this. If you look closely at 4 and the 6, 4 in the numerator, 6 in the denominator, what do you notice? They share something. They share a common factor. Anybody know what that common factor is? 2. Notice 4 can be written as 2 times 2. Notice how 6 over here can be written as 2 times 3, which means they share the common factor of 2. And what can we do with those common factors? We can cancel them out. So those 2's are gone. But if you look even closer, look at that 15 and the 5. Don't they also share a common factor? What do they share? 5. This 5 can be written as 5 times 1. This 15 right here can be written as 5 times 3. Which means we can come over here and cancel out the common factor, 5. Now look at what I have here. Look at the numerator. I've got a 2 and a 1. What do you get when you multiply 2 times 1? You get a 2. Notice down at the bottom, the denominator. I've got a 3 and a 3. What do you get when you multiply 3 times 3? You get a 9. Okay, so we can skip that 20 over 90 by first, and this is the steps that we follow, we can simplify and cancel out the common factors. Simplify by canceling out the common factors that we see both on the top and on the bottom. Of course, whatever we have remaining, that's what we're going to multiply. So what we're going to do today is we're going to use that same technique when it comes to our rational expressions. Because if I try and multiply straight across with these rational expressions, oh my goodness, you're going to run into all kinds of trouble. It's not impossible, but you do make things harder for yourself. It's much easier if you cancel out those common factors first and then multiply. We want to make things small, not bigger. The smaller numbers that we can work with, the better. Same thing is true with our rational expressions. The smaller we can make the expression, the better. All right, so let's see how that works over here with our rational expression. As I said, we're going to find common factors so that we can cancel out. So the first thing I got to do is find out, can I find factors of each of these terms? Let me start with my x minus 3. X minus 3, can that be factored? The answer is no. The next question is x squared plus 9x plus 20. Can that be factored? Yes, that can be factored. So what is the factor? Well, let's see here. I know x times x will give me the x squared part. But what's going to give me the rest? What are factors of 20 that would also add up to a 9? We've done this before. Plus 5 and plus 4. That is correct. Notice when you multiply 5 times 4, you get the 20. When you add the 5 plus 4, you get the 9. So I've just factored x squared plus 9x plus 20. Let me keep going here. Let's see if there's anything else I can factor. X plus 5. Can that be factored? No. 2x minus 6. Can that be factored? Well, I notice there's a GCF. What does GCF stand for? Greatest common factor. Can anybody else see the GCF here? What goes into both a 2 and a 6? 2. That's the GCF. So if 2 is the GCF, what goes in the parentheses? 2 times what? Will give me 2x minus 6. What's that? X minus 3. That is correct. Notice if I use distributive property, 2 times x is going to give me the 2x. 2 times the negative 3 is going to give me the negative 6. All right, so at this point, we've factored all that we can. Now we're going to go through there and see if there's anything that we can cancel out. See if there's any common factors. So y'all look closely. Y'all see anything we can cancel out that you see both on the top and on the bottom? X minus 3. This x minus 3 and this x minus 3, gone. Common factors, cancel them out. Do you see any other common factors?
X plus 5.
X plus 5, gone. Anything else? Looks like that's it. So what am I going to be left with? Well, let's start with on the top. What do I have left over on the top? Nothing. Of course, I'm not going to put nothing here because I do need a fraction. So it's just like any other fraction, we're going to use 1. What do I have left at the bottom? So there's 2 things I have left at the bottom. What are they? I have an x plus 4, and I also have a 2. Now here's the deal. I could leave the answer like this. That's acceptable, which is what I'm going to ask from you guys today. Just leave it like that. Or we can take this one step further and actually use distributive property down at the bottom. In other words, I could go ahead and do 2 times x, which is 2x, 2 times 4, which is 8. So this answer right here would also be acceptable. They mean exactly the same thing. However, for time's sake, so that we can get as many problems done as possible, I'm going to ask you to leave it in this format. So a little less work than having you do the extra step. We'll get to that later. All right, that takes care of number 4. Now, if you look closely at number 5 and number 6, what do you notice about 5 and 6? They're divided. So the question is, does anybody remember how to divide fractions? How do you divide fractions? You don't remember how to divide fractions?
Up and then down.
Up and then down?
Like cross and then cross. I mean,
Cross and then cross.
like the X. I thought you guys didn't make the bottom numbers be the same.
No, I think now you're talking addition and subtraction. Okay, here's the deal, guys. Division. What we do with division is actually we change it to multiplication. So anytime we see a division, all we're going to do is change it to multiplication. However, if you change it to multiplication, you have to do something with our second fraction. What do you have to do? Flip it. We call that reciprocal. Okay, so we're going to have to multiply by the reciprocal. In other words, flip it upside down. So now instead of using 1 over 8, we're going to be using 8 over 1. And now it's just like the other ones that we were looking at earlier. Now we can multiply straight across. So if I multiply straight across, 2 times 8 would be a 16. 3 times 1 would be a 3. Of course, just like with any other fraction, if you can reduce it, reduce it. In this particular case, though, 16 over 3 cannot be reduced. So
Wait, how'd you get 8 over 1?
all I did was take the fraction 1 over 8 and flip it upside down. It's the same fraction flipped upside down. Isn't that what you get when you take 1 over 8?
Oh, no, never mind, I get it.
Okay. That's where this 8 over 1 comes from.
I thought you meant to multiply by the other one.
All right, so the steps we took here was to multiply by the reciprocal. Again, that word reciprocal just means taking the fraction and flipping it upside down. So we're going to use this technique to do the same thing with our rational expressions. Exactly the same thing, guys. We're going to come over here. We're going to change the division to multiplication. We're going to take our second fraction here, and we're going to flip it upside down. So now instead of 5 over x minus 2, we're going to have x minus 2 over 5. That's what we're going to use instead of that. And now it's just a matter of multiplying straight across. Alright, so if I multiply straight across, of course I have 2x plus 4 times x minus 2. Now remember, I said I was going to save you the work, so you don't have to actually multiply it out. You don't actually have to do FOIL method. Same thing down at the bottom, we're going to be left with x plus 3 and a 5. So this is what our answer is going to look like in factor form. Again, I could take that a step further and actually do FOIL and distributive property, but for right now we're going to leave our answer as such. It means less work for you. All right, we got one more look at number 6. Notice how number 6 is also division. What I'm going to do is go ahead and change that division to multiplication, which also means I have to take the 1/8, turn it upside down, reciprocal. And now I've got this thing right here. Now we saw this occur earlier. I could go ahead and multiply straight across and then reduce the fraction. Or if you're really paying attention, you'll notice there's a 2 and an 8. That means they share a common factor. Notice how 2 can be written as 2 times 1. Notice how 8 can be written as 2 times 4, which allows me now to cancel out those common factors, meaning if I multiply straight across, now I get 3 times 4, which is a 12, and 1 times 1, which is a 1. So do we usually write fractions 12 over 1? No. Anytime you divide by 1, you just get that numerator. So 12 would be our answer. All right, so when it comes to this one here, of course, we're going to change the division to multiplication. We're also going to flip the second fraction upside down, reciprocal. And then we're going to simplify the common factors, then multiply. So this was kind of 2 in 1 here. We use 2 techniques, all roll into that one problem. We're going to try that with our rational expressions here in a second. So when it comes to division, you just got to remember, change it to multiplication. Take the second fraction, flip it upside down. All right, so we're going to try that over here with our rational expression. I'm going to take the division, I'm going to change it to multiplication. I'm going to take this fraction right here, second one, flip it upside down. So now it becomes x squared plus 4x plus 3 all over x minus 7. So I'm using that one instead of this one. Before I multiply straight across, I'm going to factor first. That way if there's anything I can cancel out, I can go ahead and do that. Alright, so for the 4, I'm going to go ahead and leave it at 4 for right now. X plus 3, I can't factor that, so I'll leave it as x plus 3. But I definitely can see that I can factor x squared plus 4x plus 3. So that's what I'm going to work on next. What are the factors of x squared plus 4x plus 3? Well, let's see. X times x is the x squared. What can I multiply together to get the 3, but would also add up to the 4 right here in the middle? 3 times 1. 3 times 1 is 3, and 3 plus 1 is 4. Right. Of course, for my denominator, that x minus 7 is going to stay x minus 7. It cannot be factored. So now I've got everything factored. Now I can go through here and see if there's anything that will cancel out. Do y'all see any common factors that will cancel out here? X plus 3. This one and this one right here cancel each other out. Which means I have what for the numerator left over? I've got a 4 and an x plus 1. And for my denominator, what do I have? X minus 7. So this is how we're going to write our answer. Remember I said we're going to leave it in a factor form. If I asked you to go an extra step, we could actually go ahead and use distributive property with our 4 here and simplify it. But for time's sake, we're going to go ahead and leave it in the factor. All right, any questions on that? Okay, down there at the bottom of your page it says, remember, when can you simplify a fraction? Well, you can simplify a fraction when you're multiplying, and only when we have a numerator and denominator that have common factors. This is when we simplify fractions. Simplify again meaning reduce. Just like we reduce fractions, we simplify our rational expressions. Okay, the assignment that I've just given you, increasing your vocabulary. You've got 22 problems. There's 3 different types of problems that you're going to run into. 1 through 7, all you're doing is simplifying or reducing. 8 through 14, you're multiplying. And then starting with 15 through 22, you are dividing. So I'm going to go ahead and get you started and working on one of each type. That way you know exactly what I'm looking for. Now you'll notice there's not a whole lot of room to do work here, so I ask you to do it either on the back of this paper or on a separate sheet, whatever more convenient for you. All right, so let's go ahead and take a look at a few of these together. We're going to start with number 3. All right, this is number 3. All they've given me is an irrational expression. There's no multiplying, there's no dividing. All they want me to do is reduce, simplify. It's exactly what you did for homework on Friday. So here's what we're going to need to do to simplify. We're going to need to factor both the numerator and the denominator. So I need to factor x squared minus 25 first. For this one, we're going to have to use that difference of squares. Difference of squares because it's subtraction. Squares because I need to take the square root of both of these terms. So the square root of x squared is an x. The square root of a 25 is a 5. However, the factors I need, there's 2 of them. One's going to have a minus, and the other's going to have a plus. So this is the difference of squares. Those are the factors of x squared minus 25. Now I need to find the factors of x squared minus 7x plus 10. So here we go. X times x is going to give me the x squared. The question is, what factors of 10 are also going to add up to a negative 7? What 2 numbers can I multiply together to get 10? But when I add them, they give me a negative 7. Negative 2, negative 5, let's try it. Notice how negative 2 times negative 5 gives you a positive 10. But also notice how when you add them together, you also get your -7. At this point, you've got it factored. Now we're looking to see if there's anything we can cancel out. Do y'all see anything we can cancel out? The what? The x minus 5 or 6x minus 5. Those are the common factors, which means you're going to be left with x plus 5 for your numerator, x minus 2 for your denominator. Let me ask you this. This answer that I have right here, is it okay for me to cancel out the x's? No. This is our answer. Remember I told you the other day, canceling out those x's would kind of be like me giving you the fraction 53 over 52. You can't come over here and cancel out the 5's. Can't do that. Well, the same thing is true over here with your x's. 53, that's a number. That 5 and 3 are glued together. Same thing with your x plus 5. That plus sign is the glue that holds those two things together. So that's what you're going to do for me on 1 through 7. Let's take a look at another one. Let's take a look at number 11, I guess. Alright, this is number 11. Notice the dot between the two rational expressions, which means I'm multiplying. However, before I multiply straight across, what I want to do is see if I can factor anything out. X minus 9, can't factor that. X plus 1, can't factor that. X squared minus 1, I can factor that. Matter of fact, we just did one like it a second ago. It's called difference of squares. Okay. So here's what I did. I took the square root of x squared, which is the x. That's where these x's are coming from. I'm also going to take the square root of 1. Anybody know what the square root of 1 is? 1. Well, what I did was I wrote it twice. Once with a minus, then again with a plus. This is called difference of squares. So the factors of x squared minus 1 are x plus 1 and x minus 1. Let's see here. X plus 9, notice how that cannot be factored, so I'm going to leave that alone. At this point, I've done all the factoring that I can. So now I'm going to go through here and hunt down the ones that I can cancel out. So what do you see we can cancel out? By the way, guys, remember, this is no longer there. We've replaced it with x minus 1 and x plus 1. All right, so let's try that again. What are we going to cancel out? X plus 1. This x plus 1, this x plus 1 cancel each other out. Anything else cancel out? No. X minus 9, x plus 9. Can I cancel those out? No. They're different from each other. One's minus, the other's plus. All right, so what do I have left in my numerator? An x minus 1 and an x minus 9. That's what I have up there at the top. What I have at the bottom, an x plus 9. There we have it. Again, I'm going to ask you to leave your answer like this in the factored form. Now, I could make it a little bit harder, more challenging, and ask you to actually simplify this or do some FOIL method up here at the top. But we're going to save that for a later day. All right, let's try one more with division in it. Let's try, there was a good one. Let's go ahead and do number 21. 21. Don't worry about the letters. I'm not looking at letters. I'm just looking for answers. Now notice number 21, guys, that is division. I'm going to go ahead and fix that problem right now. I'm going to change that division to multiplication. However, by doing that, I am going to have to take the second fraction and flip it upside down. So I'm taking care of that right now. X squared minus x minus 56 is now at the top. X squared minus 5x minus 24 is now at the bottom. So there's my new problem. Now we're going to go through here and factor as much as we can. So I'm going to start right here. I'm going to factor that out. So I'm going to do it right over here. So let's see. X times x is x squared. I need factors of 6 that are also going to add up to a 5. So in this particular case, those two numbers are 3 and 2. 3 times 2 is 6. 3 plus 2 is 5. Those are the factors of x squared plus 5x plus 6. Now I'm looking right here. X plus 7 that cannot be factored, so I'm just going to leave it as x plus 7. There's nothing I can do with it. Times. Now I'm looking right here. X squared minus x minus 56. I'm looking for the factors. Let's see here. X times x is going to give me an x squared. What I need are two numbers I can multiply to get together to get a negative 56, but they also need to add up to a negative 1. All right, so help me out with some numbers here. What are we going to multiply together?
7 and negative 8.
Let's try it. 7, negative 8. 7 times negative 8 is negative 56. But notice when you add those two numbers, you're also going to get your negative 1. So there it is. Those are the factors. We got one more to look at. That's this one right here. Let's see if we can find some factors. I know x times x is the x squared part. What are we going to multiply together to get negative 24? And would also add up to a negative 5. Three and negative 8. Let's try it. 3, negative 8. 3 times negative 8 definitely gives me a negative 24. However, if I can add up to a negative 5, is 3 plus a negative 8 can add up to a negative 5. Yes, yes they do. Okay, so at this point I've got everything factored. Now I can start looking for things to cancel out. So look closely. We can only cancel factors if they share in common both in the numerator and in the denominator. So do y'all see anything we can cancel out here?
8 and 8.
Not 8 and 8.
Like
That's
x
not a factor.
minus 8.
There you go. That's what you meant. X minus 8 and x minus 8. Those will cancel out. Anything else?
No.
X plus 3. There's an x plus 3 on the top. There's also one at the bottom. So we can cancel those out. They don't have to be directly underneath each other, guys. As long as one's on top and one's on the bottom.
That's different.
Okay. What's that? X plus 7. Notice we can cancel out this x plus 7 with this x plus 7. Anything else? Looks like that's it. So what are we left with? X plus 2. And where is that? In the numerator or in the denominator? Where is that x plus 2? It's in the numerator. Therefore, there it is. X plus 2. That's your answer. So after all of that factoring, we end up with x plus 2. So this is why I say factoring is very important. Very important to know how to factor.